reason why I did start this is because subnetting sucks. It really, really does suck, especially when you first start subnetting. You get confused, you got to convert that to binary, you got to convert this to binary. When I first started it, it stressed me out and I didn't really know how. I became dependent on what's called VLSM calculators, which is basically just a calculator that does everything for you. I didn't want to do that anymore. I wanted to know how to do it by hand. And so one night I literally just kind of designed my own algorithm on how to subnet. And that's basically what you guys all got right now. You guys are going to see the top layer of the top 3 ones. Those are going to be the only ones you're going to concentrate on right now. Don't look at the bottom row, just because that's going to be class B addressing, which is a huge, huge network. You're not going to have to pay attention to that. So just pay attention to the top one, which is class C, which I don't know how many of you guys are in network fundamentals right now, but Stefco is a class C network. So just concentrate on class C for right now. Also, what is subnetting? Subnetting is basically taking a huge network and dividing it into smaller sub-networks. So it's basically getting a house, and instead of looking at it as a house, you're looking at it as individual rooms. It just makes it a lot easier for you to just segregate traffic. It just flows a lot better that way. Also, so I'll go ahead and show you what my algorithm is. When it comes to subnetting, the only thing you're going to have to remember if you're going to subnet my way is 128 and /25. That's the only thing you guys are going to need to remember. That's the only thing. Everything after that is literally simple math. If you want to go step by step, all you have to do is look at the 128 and laser. What's half of 128? 64. And you literally just do that till you get to the number 1. Amber, what's half of 64?
32.
I know. Tutti Fruits. What's half of 32? 15. Mr. Jenkins, what's half of 16? 8. This might be a little hard for you, Mr. Dalton, but what's half of 4? I mean, half of 8.
That's what you want to confuse.
Half of 8.
Half of 8 is 4.
Okay.
I know the next one now.
You do? You sure? For you? And I think half of 2 is 1.
I think.
That's all you're going to have to remember for the first part. And do you see why the only thing you're going to need to remember is 128/25? Because everything else other than that is just going to be simple math. For the /25, all you're going to have to do is just add 1. That's it. So, what's 25 plus 1 total?
26.
And even I can manage the plus 1. I never go past 30, just because you're never going to have a subnetwork that's past 30, not that I know of. So just concentrate on getting to 30, and that's it.
20 and 30.
Huh?
20 and 30.
Oh.
Maybe you can't manage.
What happened to 29?
Okay, there we go.
We got rid of it. It doesn't exist anymore.
Yeah, it never happened. But yeah, that's the key that you guys are going to use in all the subnetting I'm going to teach you. Just with this information, you're able to subnet anything. You could do classful subnetting, which is basically subnets that have the exact same amount of hosts each time. And then there's the variable length subnet masks, which are the ones that require different hosts, so you kind of have to adjust your subnets a little bit. For instance, we'll go ahead and concentrate on what is called classful subnetting. Wanted to teach you guys classful subnetting first, just so you can get a handle on how to use the algorithm. Classful subnetting is relatively easy, so you guys will be able to do it with no problem. But I want to just teach you guys how to use this key right here. Because like I said, the key is going to tell you everything you guys are going to need. Let's say Mr. Dalton told us to go ahead and subnet this address. 192.168.1. .0. So that's going to be what's called our network address. And let's say it's a /24. So let's say he also wants 3 subnets using this network address. And if he wants 3 subnets, he's going to want 50 hosts in each one. So I'll go ahead and put that 3 subnets. And again, if you don't really know what subnetting means, basically what I'm going to be doing is getting this network address and turning that into 3 smaller networks, 3 sub-networks. Okay. First, you're going to have what's called the network address. Then, in between that, you're going to have the hosts, which are basically going to be the addresses for your computers, your printers, servers, anything like that. After that, you're going to have your broadcast address. To create a simple analogy of what those actually are, imagine if your network is a house. The network address is going to be basically the address of the house. The hosts are going to be everything that's in the house, so it's going to be your computers, it's going to be your printers and everything. Broadcast address is going to be your address to get out of that house. So in every single network scheme, you always have to reserve 2 addresses for the address to your network or your house, and the address and how to get out of there. So, like I said, let's say Mr. Dillon gave us 192.168.1.0. So the first subnet, we'll go ahead and just call it subnet A. It's going to be 192.168.1.0. And he wants 50 hosts on them. When it comes to subnetting, you can only go over. If he wants 50 hosts, and all of these right here are the number of hosts that these subnets can handle, so I'll go ahead and label hosts. Which one of these sections would support 50 hosts?
64.
64. And so we know that we can only give this subnetwork that many addresses. Let's go ahead and just jump to subnet B. This is where the algorithm key is going to come to play. To be able to quickly find what the next network address is going to be, all you have to do is be like, okay, so this requires 50 hosts, and like you guys said, we're going to be looking at that one for that network address. And what you do is you see, okay, there's 64 on there. What's 64 plus 0?
64.
A little hard, I know. All you had to do, just get that last guy right there, and just add 64, which is what you're looking at because he wanted 50 hosts for that address, and that's that. So, let's go to the next subnet. Again, he wants 50 hosts for each one. So, we're going to go ahead and say, okay, this has 64 hosts. Obviously, you can't do 32 because, like I said, you can't go under. So we're going to go to this guy again, which is classical subnetting, it's the exact same amount of hosts. And we'll go 192.168.1. And then 64 plus 64 is 28. Just by doing that, you've got the network addresses for all your subnets. For the broadcast address is always going to be the last usable address on that subnet. It's going to be the last one. So, I'll go ahead and write out. And if you want to find out what the last one is, all you have to do is just look at the next address that the next subnet is using, so the network address, and it would just be the address that's before that. So what's 64 minus 1?
65. Or 3, sorry. Okay, that is 1.
And then using that logic, what would be the broadcast address for Subnet B?
27.
So you're basically using like our cut sheet in our final project down below. So you're not putting in like the /26, for example. Is that actually unnecessary in your cut sheet?
You can use /26 if they want to know the if they want to know the subnet mask, you can use that, and I'll go ahead and explain subnet mask at the very end. But yeah, it does kind of become necessary, and it's a little handy tool, especially when you're doing variable length subnet mask. What I usually like to do is like subnet A, I'll put, okay, that's /26, now I'm going to do /26, and now I'm going to do /26. Just so it's like easy reference, so I can be like, okay, I just need to look at that guy right there, just need to look at that guy right there, just need to look at that guy right there. You kind of get what I'm saying? So you usually like to use it as reference. And also, the last one is just a little tricky, since you're not looking at the next network address, since there's not another network. So you kind of create a pseudo network. Again, 50 hosts on subnet C, and so 128 plus 64. How much is it? So if there was going to be a next network, it would be ending in 192. So 191. So 191 is going to be the last broadcast address. That subnet doesn't exist, so we can just go ahead and erase that. And other than that, it's just basically simple math logic to find out the hosts. Okay, so for this subnet, you're using the .0 for the network address, and you're using the .63 for the broadcast address. For the hosts, and then it's just going to be everything in between those guys right there. So that plus 1 is going to be 1, and then the one address before that, 62. And that's it. So you just completely subnetted that next network. So what would be the next address the host can use for subnet B?
55, bed 26.
And then what would be the last one that you can use?
26. 26.
And then what's the first usable host for subnet C? Really messed up thing. Alright, and just by plugging in the addresses that are in between the network address and the broadcast address, you went ahead and completely subnetted the address that Dalton had given to us. So you guys kind of understand how to use the algorithm now? Basically, all you really have to do is think, okay, so 50 hosts, this thing right here is going to support that, so we just know it's going to be 64 in between each last one. So it'd be 0 plus 64 equals 64. 64 plus 64 is 128. And just by having those network addresses, just by using simple logic, you're able to actually just figure out everything else. Using this way, you don't have to convert to binary, you don't have to do any of that kind of stuff that makes subnetting extremely difficult to understand at first. So that's why I kind of prefer that way, and everybody else that I've talked to much prefers it that way also. So yeah, that's basically what classical subnetting is. Go ahead and erase that. Does anybody have any questions before I move on to class list subnetting?
And the 2 and the 1 doesn't matter if let's say you have 31, 32, doesn't matter.
What's that? Oh.
That's in the bottom. You have 30, 29, 30.
Yeah.
The next one is 31.
Oh yeah, /31, /32. You don't really need to, just because
You never get them.
you're never going to use that. Yeah. The only reason why you would ever, well, I can't think of a reason why you would ever use that.
There's not really a reason.
Yeah.
Because you have to have the extra 2, you know how you got the host and you got the broadcast? You have 2 added on to everything. If you're looking at a /31, that's 2, which means you only have a host, you only have a broadcast. There's nothing usable in between it.
Yeah, because like I said, remember, you always got to have 2 dedicated to the network address, and you got to have 1 dedicated to the broadcast address. You can't use those for hosts at all. Like I said, that's the network to your house, well, that's the address to your house, and that's the address how to get out of your house. What we're concerned with is everything that you can use in there, or usable hosts.
Actually, the minimal functioning network would be 3, and that would turn out to be a 4 anyway. Which is 30.
So, like, let's say you just needed a network with only 2 hosts. You would do the 4 because one of them is going to be reserved for the network address and the other one's going to be reserved for the broadcast. So it would have to be that 4 right there. Okay. So you guys ready for Stucco? You bet.
Yeah.
Okay. Let's look at what Mr. Apperson wants from you guys.